Materials and instruments needed to make one experiment: a closed wire in the shape of an ellipse, one small ball, black or dark sand, white sand, a water tank similar to a fish tank, white Play-Doh to simulate glacial ice sheet, several ice cubes, and ice cubes with dark sand. Tips and tricks. Prepare the ice cubes well in advance and add just a little bit of dark sand in the ice buckets, otherwise the cubes will sink rapidly and floating is important to observe melting. Sand must be clean. If you cannot buy it, you can wash it yourself with water and filter it. Tutorial step by step. Use a closed wire in the shape of an ellipse and one small ball to simulate Earth and explain Earth eccentricity, axial tilt, and precession. Prepare the water tank with white sand and ice sheet. Put ice cubes with dark sand in the tank and observe the melting and sediment deposition. Explanation. Marine sediments deposited on the ocean floor provide evidence of changes in Earth's climate. Both continental and marine sediments are markers of the Earth's environment when they were deposited. Thus, they have registered how the environment of our planet has changed, including how climate has changed over time. Some of the most significant climate variations in Earth's history are the glacial-interglacial oscillations. Glacial and interglacial cycles have been driven by changes in the orbital pattern of the Earth, Earth eccentricity, axial tilt, and precession that have periods of about 20 kiloamperes, 40 kiloamperes, and 100 kiloamperes. These cyclic variations are known as Milankovitch cycles, and they determine the distance between the Earth and the Sun. These cycles impact the seasonality and location of solar energy around the Earth. Changing the distance to the Sun determines how long the radiation travels to reach Earth, subsequently reducing or increasing the amount of radiation received at the Earth's surface in different seasons. Understanding the causes of natural climate changes is important to understand our climate system, in particular when and why climate changes, and also helps to assess the human impact on climate variability, one of the greatest challenges for modern society. At present, not only scientists, but society in general is gaining awareness of the urgent need to limit climate change effects and understand the causes and effects of climate change. To do so, marine sediments are exceptional archives that can provide diverse information on past climate scenarios. Ice sheets are highly sensitive to fluctuations in temperature. Colder temperatures and moisture-bearing winds have resulted in a larger ice sheet, while warmer temperatures result in glacial melting. Both have left an imprint in marine sediments. Changes in sediment composition can therefore tell us how and when climates have changed in the past and in turn provide insight to further understand global climate and future climate change scenarios. Possible questions are: why do ocean sediments change between glacial and interglacial periods? Or how can we collect samples? How can we analyze them? And is climate change bad or good? Further information. After collecting samples from the seafloor, they are prepared and analyzed in a number of ways. X-ray fluorescence. Clay and carbonates need to be removed first. Then the sample is molten to form a transparent slide. And mass spectrometry. Samples are dissolved with a strong acidic mixture. Some additives might be needed to increase resolution. In most cases, students will not be able to do this for real, but teachers can design experiments that simulate some of the stages. Example: carbonates removal, melting, acidic dissolution, etc.